So, today is February 26th, Monday. Trying to jump ahead. Notes to ellipses. Standard form, I still think you did these last year, but maybe not. Standard form for an ellipse looks like this. H and K is the center, so that kind of matches the circle, right? Like, don't worry about the A and B business. But for the circle, the center was at HK. It's the same thing for an ellipse. So there's lots of overlap between the conic sections. And the center being HK is one of those places. The only difference between these two equations is where the A is. And it's not really a big deal. It's that A is always bigger than B. But that kind of doesn't matter. And we'll see that when we get to the graph. I don't know whether to say it now or the graph. I'll say it now and it'll make more sense when we do the graph. However, whatever number is under x, you go that many in the x direction. I always felt like that makes sense. If it's under x, go that many in x. If it's under y, go that many in y. All right, gentlemen, please, shh, focus. Thank you. If it's under x, go that many in x. If it's under y, go that many in y. And for that purpose, it doesn't really matter whether you call it A or B. Let's sketch an example and see what I mean. So the center would be at 2, 3. So over 2, up 3. And then again, for ellipses and even when we do hyperbolas, for some things, for graphing, it doesn't matter who's A and who's B. 4 squared is under the x, so I'm going to go 4 in the x direction. Go 4 in the x direction. And then I'll go 5 in the y direction. 5 up and 5 down. Another way to think of ellipses is, they look kind of like circles. It's kind of a squish circle or a stretch circle, however you want to phrase it. But one way to say that is the x radius. It's not the official term because, 4 isn't the radius, but you go 4 in the x direction. It's like it has a different radius in x and in y. And that r squared, a squared, b squared, that's another sort of connection to the circle. And then, again, draw a nice, symmetrical, well-rounded ellipse. It's not a diamond. It's not connect the dots. Part B. The center, then, would be... Let's start picking on people. Dia, how about the center for part B here? -5, -3. -5, -3. Good. Abby, how many left and right should I go? There's my X stuff. Yes, but did you know that other than McKenna telling you?
No.
Okay. 3 squared is under the X. So we'll go 3 left and right.
Thank you.
You're welcome. So we'll go 3 left and right.
No, I was like the other one who was doing that. I couldn't always do it.
Michael, how many up and down should we go? 5. And then again, make a nice oval. Don't play connect the dots. Yeah, my oval still needs some work. It's okay. All right, part C. 3 more volunteers. Where you can see your names there. Jonathan, how about the center? Yes, it is. Jameson, how many left and right should we go?
6.
6. Oh, off the graph a little bit. That's okay. And Mariana, how far up and down? 3. And so we did all 3 of those graphs without really caring who's A and who's B. Again, A is the bigger one, B is the smaller one, but when it comes to graph, it doesn't really matter. If it's under X, go that many in X. If it's under Y, go that many in Y. The length of the major axis, I feel like this should make sense here. The length of the major axis is the length of the longest part of the ellipse, or just like the longest axis is the major axis, and the minor axis is the shorter axis. It's like, yeah, those words make sense. They mean what we think they should mean. So, number 2, what is the length of the major axis in 1A above? So, how long is the major axis? Let me highlight it, maybe though. How long is that axis? 10. So be careful. It's not. I mean, we used 5, but it was 5 up and 5 down, so it was 10. And then the minor axis would be 8. So, I mean, it's an easy answer if you're looking at the picture, but sometimes people will answer 4 and 5 there instead of 10 and 8, because I guess they're just not thinking about the picture. The axis is all the way across. All the way across. So if you went 5 up and 5 down, it's not 5, it's 10. I mean, that's simple, but again, the common mistake is to put the half of it. All right, number 3. Let's see if we can do this without even drawing a picture. I think we probably can. Cadence, how about the center of that thing? 6, -9. All right, we're going to make Dylan think a little bit here. How long is the major axis?
20.
Good. You didn't have to think too hard. All right, so we went 8 left and right, 10 up and down. 10's the bigger one. But again, we went 10 up and 10 down, so our major axis is 20. Rebecca, how about the minor axis?
16.
16. Is the major axis in the X direction or the Y direction? Zainab, which direction is this thing going? Whichever one's bigger, right? We went up and down 10, left and right 8, so we went bigger up and down. So the major axis is on the Y, in the Y direction. Again, that means that A is 10 and B is 8. We don't really care yet who's A and who's B. We'll get there in a moment when we do. It's just A is the bigger one. That's all you have to remember for ellipses. Number 4. Oh man, I can draw popsicle sticks all day long on this stuff. Danny, how about the center? 11, 0. Jacob, how long is the, there you go, poke Macy so she's ready. Jacob, how long is the major axis for this ellipse?
9.
Well, that's the common mistake. How long is the major axis?
What's wrong with that?
18.
Double it, because it's 2 on both sides.
Well, yeah, it's 9 on both sides. So you're going to go 9 left, 9 right. So 9 is important, but if you go 9 on each side, you're at 18.
I'm going to be honest, I'm like half paying attention.
I figured as much. Macy, how long is the minor axis? How long is the minor axis? The other one, 14. And then, Victoria, is the major axis in the X direction or the Y direction?
X direction.
X direction. We went bigger, more in the X than we did in the Y, so it's an X direction ellipse. Okay, now we start to get a little bit Foci, does that sound familiar? I'm still thinking you guys did this last year, but you're saying no. Oh well. Every ellipse has two foci. That's the plural of focus. One focus, two foci. The two foci lie inside the ellipse on the major axis. Inside the ellipse, they lie outside the, well, actually, I would say they lie inside the hyperbola. They're the focus of the ellipse, so the ellipse is sort of focused on them, is one way to remember that, on the major axis. And then this is one definition of an ellipse that if you use this definition, you can come up with an equation. Maybe we could turn that into a bonus question, but we'll see. The sum of the lengths from the foci to a point on the ellipse is constant. So like if you look at this picture, that distance plus that distance is a constant number. And so even though this point over here is different, the sum of those two distances is always the same. The sum of those two distances is always the same. And so here's a definition of an ellipse using that. An ellipse is the set of all points in a plane, the sum of whose distances from two foci is constant. That's what makes it an ellipse. And you can see that that's sort of related to the definition of a circle. Right? A circle is all the points that are the same distance from the center. But now it's like we have two centers. And we still have that same distance idea, but instead of same distance from one center, it's like same distance from two centers. That's where an ellipse comes from. All right, to find the foci, we use this equation. Okay, borderline confusing here because it's like we've seen that equation. Wait, no we haven't. A squared minus b squared equals c squared for the foci. The good news is if you use the plus, if your brain thinks a squared plus b squared equals c squared because you've used that hundreds of times maybe. If you do the plus sign, you will end up with your foci outside of the ellipse. And so hopefully that would be a clue that something went wrong. So again, there's a built-in check. If you use the plus, it's not going to look right. So hopefully that helps. A squared minus b squared. And then that is the distance. Let's be careful here. Let's label it, I think. That c is the distance from the center to the focus. C is the distance from center to focus, and it's on the major axis. So we can word that really funny, but it's just go on the major axis however far out. Yeah. Okay, so number 5. Let's find the foci of the ellipse with that equation. Okay, well I know they're going to be from the center, so let's start by finding the center. So Sophia, what's the center of that equation, or the center of that ellipse? Negative 3, 1. Ethan, am I going to get to the focus, am I going to be going left and right or up and down? Or have I said enough for you to know? They're on the major axis. So for this one, that's going to be up and down. So I know I'm going to be going up and down to get to my focus. Now, I don't know that I need to write that, but I certainly need to think that. I'll be going up and down from the focus, from the center to get to the focus. All right, c squared equals a squared minus b squared. So now it does matter who's a and who's b because we're subtracting. A is always the bigger one. So 100 minus 64 is c squared. So this was a nice one. C is 6. What would have happened if you'd have got A and B backwards? You'd have c squared equals negative 36, and hopefully you'd think, wait a minute, that doesn't work. And it doesn't work because A has to be the bigger one. So there's lots of built-in checks as you do conics and ellipses in particular, that if you get something backwards, if you're really paying attention, you'll realize that something doesn't work and then go fix your mistake. Okay, so 6, but that's the distance up and down. So which, how to phrase this, which coordinate should I adjust? I feel like this is a dumb question, but which coordinate should I adjust to accomplish an up and down change? The y. So I'm going to, my focus, I'm going to adjust the y coordinate by 6. And depending on the answer choices, that might be enough. I'm going to go negative 3, 1 puts me at the focus, and then this really sort of emphasizes, or puts me at the center. And then from the center, if I go up and down 6, I've got the foci. Now, again, depending on the question, it might actually want you to do the plus 6 and the minus 6. So we'll recap the foci really quickly. A squared minus b squared equals c squared. C is the distance from the center to the focus, but it's got to be on the major axis. So a squared minus b squared, that gives you your distance. And then since we knew this one was an up and down, we would adjust the y coordinate. You know what? Why don't you try number 6? Same question, different numbers. Try number 6. All right, so I find the center, and then I identify that the major axis is left and right. And some people even go so far as to like do a little picture, help them visualize this is a left and right thing. So I know my foci are left and right. Looks like ET there. My foci are left and right from the center. So I find what that distance is. And if they're left and right, that means I need to adjust the x-coordinate. So x-coordinate plus or minus that distance, comma the y-coordinate. Questions? Are good? Graph the eclipse with that equation. That doesn't look like an eclipse. An ellipse? That's your fault. The eclipse thing. So let's group the x stuff. 9x squared plus 36x. Leave a little space and group the y stuff. 4y squared minus 32y. And then let's just move that 64 out of the way to the other side. Does that setup look familiar for what might come next? Complete the square. Yes, complete the square. I do need to do one thing first before I do half it, square it, add it. I wouldn't say grouping isn't terrible. I would say I already grouped the x stuff and the y stuff. But I bet, what do you want to do? Factor. What do you want to factor? Although even then, be careful. Let's factor out a 9, but not the x, because I want the x squared there. You're right. If you were factoring, you'd factor out a 9x. But it's not that I'm factoring. I just want the 9 out of the way. And then I can half it, square it, add it. And for the y stuff, let's take the 4 away, and then half it, square it, add it. Half it, square it, add it. That's my complete the square method in 3 letters. HSA? Half it, square it, add it? Sorry. So v over 2 is 2. That's the half it part. Square it, I get 4. So I will add 4 to complete the square. I need to be careful here, though.
You also need to add 4 to the others.
Do I need to add a 4 to the other side?
4 times 9.
I need to add 4 times 9 to the other side. Because I wrote plus 4, but I didn't really add 4. I really added 36 because there was a 9 out front. So that's a common mistake right there. You're so used to, hey, you got to add 4 to both sides. It's plus 4 plus 4. Well, kind of, but I didn't add 4. I added 36. And d over 2 is negative 4. Square it, I get 16. But I didn't really add 16. I added 64, which is convenient for the computations on the left-hand side. So now I've got 9 times x plus 2 squared plus 4 times y minus 4 squared equals 36. I'm closer. That still doesn't look like an ellipse, though. I need the 1 on the other side. So how would you like to accomplish getting a 1 over there? Divide by 36. And it's especially convenient that everything reduces and it looks nice. X plus 2 squared over 4 plus y minus 4 squared over 9 equals 1. And so now I'm ready to graph. Let me get through everybody today. Don't do that often. So Leah, where's the center of that ellipse going to be? Negative 2, 4. Andrew, how many left and right should I go?
You should go 3 rights and 2 left.
Wait, say that again?
You should go 3 up and down and 2 left and right.
Okay, you took Katie's answer, but that's okay.
Oh.
I should go 3 up and down and 2 left and right. You were correct.
Oh, oops.
Again, I'm not even really worried about who's A and who's B. If it's under X, go that many in X. If it's under Y, go that many in Y. And there's my picture. And it didn't ask about focus, so I guess we're good. Until we get to number 8. Find the foci of the ellipse with that equation. Well, once again, we get to complete the square. Maybe it's a little easier because I don't have to factor anything off the y. It's a pretty minor step to easier. So I'm going to press pause, and you're going to get it to the standard form. So there's the equation. There's the center. The major axis is y, so we'll go up and down to get our foci. And so we'll adjust the y coordinate. Okay, now this thing about astronomers. But the point is, I assume they thought the orbits were circular at first because they're almost circular. And so if you've got a rudimentary measuring device and it looks circular, you probably think your device is just off a little bit and you think it's circular. And so those pictures, like you probably know that the planets have elliptical orbits, but usually when we draw them or when you see them in textbooks, they're like obviously ellipses. But in reality, they're not really that elliptical. They're a whole lot more circular, and they're like just barely ellipses. Well, there's a measure of like how elliptical versus how circular an ellipse is, how stretched out it is. Measure the ovalness of an ellipse. And it's called eccentricity. Very eccentric. Some ovals are more eccentric than others. The eccentricity of an ellipse is the ratio of the distance from its center to its foci, that's C, to the distance from its center to one of its major endpoints. That's a lot of words to say eccentricity is C over A. C being the focal distance, A being the distance from the center on a major axis. So for an ellipse, C is always less than A, right? The focus is always inside the ellipse. And so if C is less than A, then the ellipse eccentricity is always between 0 and 1. And the closer it is to 0, the more circular it is. So here's just a couple pictures. That eccentricity is 0.3, and you'd have to look really hard. Like if that didn't have a scale, you'd just say, oh, it's a circle. And then you looked really close, and you're like, wait a minute, it goes 3 up and down, and like 3.1 left and right. So it's not a circle, it's barely an ellipse. But its eccentricity is low. Eccentricity is high, then it's more ovally, if that's a word. Here's just some random information. The orbit of our moon has an eccentricity of 0.0549. Okay, well, look at how close 0.316 was to being a circle. Like that's pretty circular. So 0.0549, like that's really close to a circle. Same with all the other planets. 0.2, I guess that would be the most elliptical of the orbits. But even that's not, that's still pretty circular. So when you look in those textbooks and they draw the planets orbiting like that, like no, if they drew it to scale, they'd all pretty much be circles. Especially like Neptune, 0.0086. I mean, that's a circle. So looking at those, which has the most elongated orbit? Mercury. Mercury by a long way. And the most circular is Neptune. Oops, is it? 0.006. Yep, Venus. Just kind of interesting stuff there. Determine the eccentricity of an ellipse with this equation. Eccentricity is C over A. So I need to find C and I need to find A. Let's see. A. Oh, it definitely matters who's A and who's B on this one. So what's A equal to? 5. And B is the square root of 20. We don't even need that though. But A is 5. I need C. C squared equals A squared minus B squared. So that would be 5. So eccentricity is C over A, square root 5 over 5. Eccentricity is C over A. Number 10 also asks for eccentricity, so I'm headed for C over A. The major axis of an ellipse is length 10, and minor axis is length 3. How does that help me? What do I learn? Wait, A is 5, and B is 1.5. So I know A. It's 5. C is going to be ugly because of the 1.5 thing, but 5 squared minus 1.5 squared. Let's see here. 25 minus, does anybody know what 15 squared is? You had memorized that in 8th grade, right?
So how come we're 9 and subtracting?
What's that again, Jason?
9 being subtracted. Because subtract square is 20 for 9.
I did A squared minus B squared.
Oh, okay.
So yeah, be careful about A versus A squared, B versus B squared. So, I don't like this. 22.75? So we'll just leave it as the square root of 22.75 over 5. That's less than 1, so I have some confidence in my answer. Hey, what's the area of a circle? Pi r squared. And remember I said early on that A is sort of the long radius and B is the short radius, kinda. Well, that idea fits really well with the area of an ellipse because it's still pi times r but where the r's are different. So that idea of having a left-right radius and an up-down radius, if that makes sense to you, then it's easy to know the area, because it's still pi times the two different radii. If that feels weird, then don't worry about it. Just say area equals pi times a times b. But to me, that different radii thing helps make sense of a lot of things. I'm going to go a left and right, b up and down. So it's still pi r squared, sort of. All right, so what are we up to? Worksheet number 2, I think. Yeah, worksheet number 2.